10, video number 10, the last lecture.
Woohoo! Our learning target here is focused mostly on understanding how different covalent molecules can interact with each other. Because in the last video, we saw how sometimes you can get a polar molecule. What happens when you have a whole bunch of polar molecules?
That pluses and minus ends are going to link up and be attracted to each other.
Mm-hmm. So intermolecular forces in general are just a force of attraction between molecules. So this
Notice,
is only for covalent things.
and it's not a real bond.
Correct.
Not at all.
Nope. And the one type is called a dipole-dipole force. It's extremely weak. It's where one end of a molecule that's positively charged.
And that means partial, that squiggle means partial positive.
Partial positive charge, yep, it's a Greek lowercase delta, okay, is attracted to the oppositely charged portion of some neighboring molecule, right? So the chlorine, which has a partial negative charge due to its high electronegativity, is attracted to the hydrogen, which has a partial positive charge because of the low electronegativity on another molecule.
Right.
It's a polar-polar attraction. Poles are constant and they increase the attraction. So it's
And notice, if we ever are to draw them and line them up like this, we use dashed dotted lines because it's not an actual
bond.
So we show it with a dotted line.
Sometimes it's called a coordinate covalent bond.
Ooh, no.
But it's not.
Yeah,
it's don't go there.
Coordinate covalent is completely different. That's where the H comes onto the ammonia and becomes ammonium.
Yes.
Hydrogen bonding is this particular thing. Oh, you still got pictures. This particular same thing, I would call it a dipole on steroids. So now it is the same dipole with a positive and negative end, but specifically now the H on one atom, or the H atom of one molecule, is attracted to the nitrogen, oxygen, or fluorine of another molecule. These specific conditions need to be met for it to be considered what we call hydrogen bonding. Now, this is a intramolecular force that is so strong that it will increase the boiling point. So it will increase, right, all that stuff, because now I have to really overcome this extra attraction between the molecules.
The classic question is, what is the name of the intermolecular force of attraction that causes the unusually high melting and boiling points of water, which
Correct.
is a covalent compound, which is comparatively very stable when other covalent compounds are not? And the answer is because water's got hydrogen bonding. It keeps the molecules stuck together.
Yes.
It's the reason why capillary action works. It's the reason why ice is less dense than liquid water.
And this is one of the things that you guys might have done in middle school or 8th grade science, where you take the penny and you drop the water on and you see it bead up and you count how many drops before it actually overflows. Well, the reason why it's sticking together the way it is, and it is so sticky,
hydrogen bonding. Every one of those atoms in there, and molecules, wants to stick in a very coordinated fashion to its neighbors, which creates this extreme surface tension, a lot of these funky properties of water.
Oh, absolutely.
That
first the shape, and then second this extra intermolecular force. So now notice in the picture you have the blue hydrogen of one molecule attracted to the oxygen of another molecule, and it just so happens to be the definition. Hydrogen of one molecule attracted to the nitrogen, oxygen, or fluorine. So because that condition is satisfied, we would call this hydrogen bonding. And what we need to do is get good at picking it out so we can tell if the particular compound has hydrogen bonding with it. Okay?
it's not truly an actual bond, it's just the strongest IMF, intermolecular force, that we will be speaking of.
Yep, you got to know it's not a true bond. And the reason why it's so tricky is we call it hydrogen bonding. It sounds like it should be a true bond, doesn't it?
Right. It sounds like hydrogen is bonded to something.
And it's
Well,
not.
It's not. It's just
attracted.
really, really attracted to something else.
Right. So
Intermolecular forces in the phases of matter. So in solids,
they got to be super strong.
very strong intermolecular forces.
They're locked in.
The atoms are stuck together. They don't want to move. I ain't moving.
Right.
No, I ain't
I'm
going
moving.
nowhere. You're going to put a lot of energy in me to get me to be a liquid and then a gas.
So then liquids are touching, So they have some.
intermolecular forces. Sure. Yeah.
You can't get them to move apart from their neighbor,
Yeah.
but they're able to move around. You can pour water.
Right.
So they're able to move.
Gases, on the other hand, very, very few intermolecular forces, especially if we're treating them as future keyword ideal gases. They have very weak intermolecular forces. We want to believe that an atom or molecule of gas has zero attraction for another one. Got you all. Right.
Right,
Sorry,
so-
I'm Italian.
All right. So it makes sense that a solid has a much stronger intermolecular force. So a very common question we have here is, so why is bromine a solid? Or I'm sorry, why is bromine a liquid while chlorine is a gas?
Well, bromine has a higher degree of intermolecular forces.
Done.
As you go down group 17 halogens, you go from a gas fluorine to a gas chlorine to a liquid bromine to a solid iodine. Why is this?
Well,
As you go down the group,
they're
the intermolecular forces are increasing. Therefore, the ones towards the bottom are solids and the ones towards the tops are gases.
That's it. I think.
Ooh. That's all
We just finished the
for
unit.
chemical bonding. This was the first unit where these lectures really were the tip of the iceberg.
Yeah.
Seriously, if you look through the practice and compare it to the notes that you took, even if you paid the closest of attention,
Yes.
you will have gaps that need to be filled
Yes.
because you need a chemistry teacher to help you through
Yes.
those things that you need help
So
with.
pay attention to your bell work. Pay attention to the mini lessons.
Pay attention to the Pogles.
Yeah, and practice, practice, practice. We got to get these things to where we practice till we can't get them.
Wrong.
And some of these are going to take a lot more practice. Notice there is a
Especially-
lot more practice.
Polarity.
Yep.
Lewis diagrams.
Drawing these
Ionic
things.
diagram.
Naming
Drawing
these
bonding.
things.
Drawing bonding is going to be tough for ionics and covalents. Naming is going to be tough for ionics. Intermolecular forces of attraction and polarity is going to be tough.
Yep.
Because nobody wants to understand that electrons are pulled unevenly or evenly, and
Yep.
symmetry matters.
Well, let me tell you, the polar bear is stronger than the penguin. Just saying.
Certainly is. And the other thing is we didn't say it, but if you're making molecules or trying to draw pictures of them in your practice, ask us for a model kit.
Yeah.
We have representatives of these things that you can literally get your hands
You
on.
can play with
And
them.
this is the first unit where it wouldn't be just you playing with wooden balls.
Seriously,
Pause.
that was a pause, mister.
Whole class paused. Paused everybody at different points and different times. This is like a temporal pause.
Oh, because we're all watching this video at different times. Oh, but wait, none of you are listening anyways. You're all
Yes,
bumping.
bumping
Go
tunes,
figure.
whatever. The answers to the unit exam are as follows.
Yeah. Wait till,
AA, BCD,
wait till next unit when we stop putting writing on the board. I'm just
ADA.
saying.
BB,
We need y'all to listen in.
CBDDA.
I think it's enough of our soapbox. Peace out.
Peace, y'all. The answers to the unit exam are as follows.